Panning is the technique of shifting the amplitudes of a sound source between sound channels. Stereo panning is the technique of shifting the amplitudes of a sound source between the left channel and the right channel. Spatialization is the technique of setting a sound in three-dimensional space. Natural sounds exist in space, and our brains are experts at determining the location and direction of sounds. Adding spatialization adds curiosity and depth. We use many cues to determine the location and direction of a sound. In the sound realm, we use amplitude, phase, time gap, high frequency content, and reverberation. A close sound is louder. A further away sound is softer. If a sound arrives at the left ear faster than the right ear, we perceive the sound as coming from the left. The delay between the ears, which informs our sense of space of the sound, we call interaural time delay. Phase information in the sound also informs our brain of the location and direction. A sound close has its full spectrum, while sound further away loses some of its high frequency content. Finally, reverberation informs our sense of space. A closer sound will appear to have less reverberation, while sound further away will have more reverberation. Sometimes, small movements of the head can greatly increase our understanding of the space of the sound. We constantly make small head movements. If a sound moves towards us, we perceive the sound as having a higher pitch. If the sound moves away from us, we perceive the sound as having a lower pitch. This is called the Doppler effect. There are three dimensions when we set a sound in space: distance, elevation, and azimuth. Distance is how far the sound is from the observer. Elevation is how much above or below the sound is. Azimuth is how much the sound is to the left, right, front, or back the sound is. Binaural audio simulates three-dimensional sound using headphones, which is two channels of audio. Binaural audio works by encoding all of the cues of the space of sound. Most binaural recordings use a mannequin with two specialized microphones inside. We can also simulate binaural audio using a head-related transfer function. An HRTF is a collection of mathematical constructs that simulate space cues on sound sources. Another technology that enables spatialization is ambisonics. In ambisonics, there are four channels of audio: X, Y, Z, and W. We can route to any number of speakers in any arrangement around the observer. Many toolkits will allow the sound designer to set each sound source's distance, elevation, and azimuth. Then, the software will automatically set each sound in space and create the four channels. Ambisonics uses mathematical models to route the four channels to the speakers. These models give each sound source a sense of space. With ambisonics, we can scale and spatialize a single recording for anything from 2 speakers to 512 speakers and beyond.